Chapter 4, Bypassing Client-Side Security. You may head on to your SAT Learning website and you may download the Chapter 4 PowerPoint. And I have also included a summary of the chapter in Chapter 4 handouts, and you may download it in PDF format. Bypassing client-side security. Let's have a recap for Chapter 1. We describe how the core security problem with web application arises because most of the client can submit arbitrary inputs. So, despite of a large portion of the web application nevertheless relying upon the various kind of measures implemented on the client side to control the data and it submit to the server. So in general, it represents in a fundamental security flaw. The user has full control over the client and the data it submits can be bypassed in any means of control. So we're seeing a different flavor how this bypassing the client-side security. And of course, this is our objective to know how to bypass client-side security in different ways. Let's start with transmitting data via client. It's kind of very common to see in most applications passing the data to the client in a form that it's not directly visible to or modifiable by the end users. So in expectations that these data will be sent back to the server and subsequent requests, often the application's developers simply assume that the transmission mechanism used will ensure that the data transmitted. So we start with the hidden form fields, and hidden form fields are a common mechanism for transmitting data by a client in unmodifiable way. But in a field like a flag as hidden, it's not displayed on screen. But however, the field name and the value are stored within the form and sent back to the application when the user submits the form. So in the classic example as security flows, that is retailing application that stores the price of products within the hidden form fields. In the early days of web application, this is quite vulnerable and extremely widespread, and by no means you will see to eliminate by this time. You can see the figures, a typical HTML form, right? And say you might be entering a product or selecting a product or entering the quantity with a kind of constraint or restriction for validation, like a maximum quantity is only allowed is 50. And actually the code behind this is it runs with a form method post, and you can see the action that we have a shop.aspx product or product equals to 1. So literally that suppose you're buying a product and you might be also including some input type tags that you might have not seen on the page because it was hidden, like the price value is 449. So notice that the form called price, which is flagged as hidden, so this field is sent to the server when the user submits the form. Although this field is not displayed on screen and it's not editable by the users. So this is solely because the application has instructed the browser to hide the field because everything that occurs on the client side is ultimately within the user's control. So this restriction can be circumvented in order to edit the price. Sometimes one way to achieve this is to save the source code of HTML page and edit the value of the field and reload the source into a browser and click that button. However, it's kind of an elegant kind of fashion way that's showing you the source code as per HTML browsers. And HTTP cookies are kind of another common mechanism that for transmitting a data by a client. Basically, this is as normally hidden form fields. These are not normally displayed on screen and directly modifiable by the users, but they can, of course, they can be modified users intercepting proxy either by changing the server response that set them or subsequent client requests that issue them. Considering the following variation of the previous example, when a customer logs to the applications, he or she will receive the following responses. So, this response set comes with the 3 cookies, and all which are interesting. The first appears to be the session token, and which may be vulnerable to the sequence or other attacks. The second appears to be sometimes a user's identifier. Okay, let's move on to URL parameters. So URL stands for Uniform Resource Locator, as we have mentioned in our previous chapter, and sometimes it's called as URI, or your Uniform Resource Identifier. These applications frequently transmit data via the client using preset URL parameters. For just example, when a user browses the product catalog, and the application may provide them with a hidden with a hyperlink to URL like the following below. So when a URL containing a parameters is displayed in the browser location bar, any parameter can be trivial actually and can be modified by the user without the use of any other tools. But however, there are many instances in which the application may expect that ordinary user cannot view or modify the URL parameters. Right? Of course, for example, that when the URL containing embedded images loaded the URL containing a parameters. A URL containing a parameters that use to load the content of the frame whenever the embedded forms, or when a form is used to post method and its target URL containing preset parameters, and sometimes when the our form uses post methods and its target URL contains request parameters, or sometimes application that sometimes pop-ups in your window, or pop-up window, or other techniques to conceal the browser location bar. Now let's move on to the repairer header. The repairer header includes the request header within the most HTTP requests, and it is used to indicate the URL of the page from which the current request originated. And for example, considering a mechanism that enables users to reset the password if they have forgotten it. The application requires users to proceed through several steps in a defined sequence before they actually reset their password. So there's some steps basically, and this value might be in the following requests containing maybe request or get or authentication or post, and the application maybe use this kind of header to verify the request originated from. Of course, capturing users' data in HTML forms. In capturing users' data in HTML forms are basically a kind of principle works in a different way in which application use client-side control to restrict data submitted by the client that occurs in some data that was originally specified by the server but was gathered on the client computer itself. And these are HTML forms are simplest and the most common mechanism for capturing these inputs from the users and submitting it to the server. Sometimes it contains some length limits. It's considered following variation original HTML forms, which imposes maximum length, maybe includes hence the browser will prevent the user from entering any more than 3 characters to input fields and so on. Okay, let's move on to script-based validations. Uh, these are input validation mechanisms that built into HTML forms themselves, and they are extremely simple and sufficiently fine-grained to perform the relevant validation of many kinds of input. For example, a user registration form might contain fields for name and email, telephone number, and zip code, which expected different types of inputs. Hence, therefore, very common to see customized client-side input validation implemented within the script. Considered, of course, most of them should be hidden, and those scripts are basically hidden from the browser as well because it was been not shown on the tags. But however, such action um, attributes like this shop.aspx question mark prod equals 2 is one kind of script validation which is identifiable to the browser, from the HTML itself, including inside the form tag. And this is kind of vulnerable of showing a script-based validation attaches directly from your one of your parameter in your form tags. And this script function validates form, of course. Capturing user data browsers extensions. And basically, these components can be captured data in various different ways, both via input forms or in some cases by interacting with the client operating system, file system, or registry. But whatever validation and processing in a tick line component performs, if it submit data to the server in a transparent manner, then this data can be modified using intercepting proxy. So take note to this. This data could be modified using intercepting proxies in just the same way as the HTML form data. For example, the tick client component supporting the authentication mechanism might capture using credentials, perform some validation of these, and submit the values to the server as a plain text. This plain text is considered parameter within the request. The validation can be circumvented without performing any analysis of attacks on the component itself. And the common browser technologies are basically uh, browser extension that you might have plugged into your favorite browser. Most likely, those are the Java applets, Flash, Silverlight by Microsoft. And this might, of course, help on performing on your browser by updating these plugins to your respective browser because might have been similar functionality that might not work on other browser if they don't have this kind of browser extension technology plugged into their browsers. So they are compiled in intermediate bytecode. They are also virtual machines, sandbox environment. They may use remote framework employing serialization, transmitter complex, and basically these are quite commonly seen on our updates. And if you're seeing some updates sent by your platform, and most of the time we are downloading and it works by installing these updates so that we could see some changes, might have some bugs or vulnerable program that used to be there before, and which means a common browser extension might fix some errors as well. Approaches to browser extensions. Basically, when the attacker needs to employ two broad techniques when targeting application that use browser extension components. So might as well, uh, this browser extension might be also vulnerable if we are adopting suspicious files coming from unknown website or untrusted website. Similarly, for those browser who are not updated, they might have postponing the updates from the control panel of their computers, and of course, eventually, those applications, particularly in the browser, will become more vulnerable. So first, he might intercept and modify the requests made by the component and requests received from the server. In many cases, this is the quickest and easiest way to start testing the components. So similarly, if you're performing also a transaction, suppose you're buying online, you might be obfuscated, or the protections of your information should be encrypted, particularly if you're entering your bank credentials, might be prone to phishing, of course. Intercepting traffic from a browser extension. Normally, if the browser is already configured, we intercept proxy and application load to client using a browser extension. You may use a request from these components and pass it through the proxy. In some cases, you don't need to do anything more than to begin testing relevant functionality, because you might intercept and modify the components request in the usual way. Now, this time, how can we handle our client-side data security? I think it's been quite common nowadays that sometimes we are insecure with many things, particularly on using the technology. And most likely, as you have seen, that the core security problem will with the web application now arises because the client-side components and the user's inputs are outside of that server direct control. So the client and all of the data received from it is inherently untrustworthy. So, which means transmitting via data via client is many applications leave themselves exposed because they transmit critical data such as product prices and discount rates. So if possible, applications should be avoided. We transmit this kind of data via client together. In virtually any conceivable scenario, it is possible to hold such data on the server and reference in directly from the server side logic them needed. Just for example, that an application that receive users order for various different products should allow users to submit a product code, and this might be a double check for the side of the users or the server, or maybe an email would be sent, right? So anyhow, it's not bad to insecure, but most likely we wanted only to secure our credentials and our informations, and of course you don't want to be compromised. And validating client generated data, basically this validating is based on the client generated data that belongs to the server. But basically, this client and transmitted to the server cannot be in principle, actually, we cannot validate securely on the client. They are all mentioned here. They are all lightweight client, control implementation on the browser extension components, which is our previous slide, and using heavily obfuscated or backline side code. And similarly, I think this is the most important factor on when uh, everything had been compromised, or even you as the users are trying to attempt, and unknowingly or unintentionally you might have been logging with the wrong credentials. Right. Logging and alerting will be there even you've been successfully logged in or use the account from another device or computer. And when an application employs this kind of mechanism, of course, basically there are kind of detection for that. You can see the integrated way of the server side intrusion. They want to defense mechanism for detection of this kind of intruders detections. For the server side, logic performs validation. They might see some validation had been occurred, or some client had been already breached, or if data had been blocked by a client side validation is received, and so on. So most likely now, in this case, when JavaScript employed, the application is still usable, and by user who have disabled the JavaScript within their browser. In this kind of situation, JavaScript-based form validation code is simply skipped in the browser, and the raw inputs entered for the user submitted. And to avoid this kind of false positive, the logging and alerting mechanism should be aware of where and how this can be arise. Thank you very much, and this will end our chapter, and see you to the next lesson.